Hi, morning everyone. My name is Yiran, and today my topic is about content-based image retrieval and recommendation. And I will give a whole overview of how the system works. Yeah, and specifically, I will introduce some parts of the system, how it works, and the knowledge gap and the further work directions. And this is my motivation and why I need to do this survey. For example, this is already shown before. We are clear about this image, this and this is very clear. This is from France, but about this one, we have no clue where it belongs to. So, if we need to find it, we need to build such kind of system to find the exactly same image or similar images. So, yeah, and continue. This is the whole structure of the system. First, we need to get the image. We can call it as a user query. We need the field feature extraction, and in order to build our databases, first we need this one, and we need a classifier to classify all the images in the database and put it into different classes, and we can compare the similarity, use the similarity measures like a matrix, and then we can get some feedback to the feature extraction, and finally we can get the result. Yeah, and I have also worked a little about the data size. There's because I have read dozens of papers, and basically most papers describe of the first three databases, and I believe these three can be used to train the classifier and evaluate the behaviors of the classifiers. And there is a lot of difference among these four different databases. And as you can see here, the amount here is very small, for Pascal Vogue, and Caltech 101 is also very small. But for the image 90 is a little bit larger because there's a lot of nodes in this website. Every node contains hundreds of images, so we can use it to do our research. And what's more, this tool already stopped update, and this tool is still updating. And the format and whether it's classified or not. I mean, we can use these three to do the evaluation and classify, but I prefer to do the multimedia platforms like Flickr and other platforms to build our databases, because currently, just as Facebook as an example, basically currently we have over 90 billion images in the Facebook, and it keeps increasing 300 millions one day. So I think it's a very big resource. And this is a collection procedure. We can extract all the 75,000 nouns from the word night, I think. And we can, based on the nouns, we can crawl the images from the Flickr or Google, and we can save it in the database. I think it's very useful. And as for the tools, we can use the many very mature tools in the Python, so it will go automatically and save all the data we need to the database. Yeah, and this goes to the feature extraction. Now currently there's mainly three feature extraction methods. First one is color, second texture, and third is shape. For the color, they used to measure, first is RGB, yeah, and the second is HSV, and for the texture one, yeah, we need to compare the texture difference between the two images, and for the shape one, there's also separated in two branches. The first is region-based. We can compare the whole image regions and find their similarities, and the second is counter-based. It's need us to find the feature inside the images, so we can compare these two different shapes and how much they are similar to each other. Yeah. And I think I focus more and spend more time on this part. It's classifiers. Basically, the polar vector machine is very popular currently, but I try to explain why a naive Bayes nearest neighbor is also working fine. So this is two different classifiers. First one is the polar vector machine. It tries to find the optimal hyperplane and to divide the two classes, but usually it doesn't work because a lot of points just mixed to each other. So we need to reflect it to a higher dimension. That will spend much more time. But for naive-Bayes and nearest neighbor, it will be very short. It don't need any learning time. Yeah, it will behave better. And there's a comparing about two classifiers. Let's ignore this one. First go to this one. For the training time, this is very good. We don't need any training time, even if we have millions or billions of images in our databases. But for support vector machine, if we got millions of databases, images, we need to spend the days of time. It's a waste of time. And for the descriptor and for these two, yeah, because the vector machine needs descriptor quantization, that is very necessary for the parametric classifiers, but it's very harmful to naive-Bayes nearest neighbor. And we don't need it. We need to store the image as its original. We don't need to resolution of the images. So this leads to another question. We need a lot of storage space for naive-Bayes nearest neighbor, but relatively we need only small space to store the images for the support vector machine. And for the distance calculation, naive-Bayes nearest neighbor only need to calculate the image to class. It will behave better and save a lot of time. But for support vector machine, we need to calculate the similarity between image to image. If there's exactly the same image as we upload one or submit one, it will behave better. But if there's no one, yeah, it doesn't work. Thank you. Yeah, it's a recommendation system. We need to find the similarity between two images, right, in order to do the recommendation. If we don't have the exactly same one, for example, yeah, it looks all the same. But how to find the similarity between two images? We need to use the sum of square differences. I have talked before in last slides. We need to extract the features, right, like color, texture, and shape, and we need to build that as a vector and like a matrix, and we need to calculate the minimum SSD, like sum of square differences, and we can compare the difference between two images, so we can do the recommendation. Thank you. And this is the evaluation part, and basically it's very simple. We can use the number of relevant image retrieved and to divide the total number of image retrieved. So it's very simple, and we need to apply the RR normalized modifier retrieval rank and to do the precision calculation. And the 0 means available in top rank list, and the value 1 indicates that there's no matching images. And this is my knowledge guide currently. Because in ordinary data scale, due to the data sparsity and bias, currently the approaches usually adopted parametric prediction models, but whether it's still suitable for current situation is still questionable. Question because the image is just growing very fast, and we don't have the time to wait for the training time of a support vector machine or other parametric classifiers. So we need nearest neighbor classifiers to help us save a lot of time. And sorry, thank you. And further work directions, and also the behaviors of nearest neighbor is very good, but we still have bad news because we need a lot of storage for the nearest neighbor, because we cannot do the relevation of the images. So that's the problem. In further work, I would prefer to do to train the classifiers only use a small sum of images, so that we're working fine for this direction. Yeah, thank you.